This is a lesson on classifying polynomials. So as you can see, we've got two different charts here set up. So I'm going to just focus in on the first one. And it's going to really be determined by the number of terms. Okay, so this is all about how many terms a polynomial has. So if we have one term, okay, it's like 8x to the fourth. Okay, that's one whole term. There's no other additions or subtractions. This would be considered a monomial. If we had two terms, like 4 minus 3, wow, turn the shapes off, 4 minus 3x, there's two terms separated by an addition or subtraction. The prefix bi means two terms, binomial. I'm guessing that you already know what a three-termed polynomial would be called. And it is a trinomial. Anything more than that, we're not too concerned with classifying it, so we're just going to say polynomial. 7x to the 10th minus 3x squared plus 4x plus 2. Okay, it's got four terms. We don't really need to worry about classifying that. Okay, I'm going to change this a little bit here. So, degree 0. What a degree 0 polynomial is going to look like, you're going to be like, really? That's bizarre. But I'll explain a little bit here. So, an example of a 0-degree polynomial would be any number. So, like -10. And the reason we are calling that degree 0 is it's really the same as -10 times whatever variable I want to the 0 power. Because anything to the 0 power is equal to 1. And 1 times that -10 gives us -10. And the classification for that, you might think, oh, it's just a number. The technical word we're going to use is constant. Okay, constant meaning it doesn't contain a variable. So it's always going to be -10 no matter what you say the variable is equal to. It never changes. That's why we're calling it constant. Degree 1, 3a. Now, again, a little strange here, but there's no exponent here, but there's really an unwritten 1. Okay, you don't see it. This is called a linear polynomial. Okay, so I have a monomial there, but it could be 3a plus 5. And when we're looking at the degree, we're only concerned with the highest exponent. So here there's a 0, here there's a 1, the degree is 1, and that would be considered linear. Degree 2, let's go 8b to the second plus 2b, again, unseen 1 here, and then minus 10. First of all, we have three terms. The exponent here is 0, the exponent here is 1, the exponent here is 2. This is the degree. It's the highest exponent. If the degree is 2, we are calling that a quadratic. And then we have a degree 3, so like say x to the third minus 1. Again, it could be any length. However, we're looking at the highest exponent here, which is 3. That would be considered cubic. And then we get to the general case of something like this. 4x to the n plus 2x to something smaller than that. So if I subtracted 1 from some number, it would be smaller. Okay, and let's just say plus 1 or plus 11. The degree of this term is 0. The degree of this term is 1 less than n, which makes n the highest number, and therefore n is the degree. And all we would say for that is it's the nth degree polynomial. Now that sounds weird until you throw a number in there. So like, let's say we had 5x to the 11th minus 3x to the 10th plus 2. Notice that here's my highest number. This one is 1 lower, just like this and this. So my degree here is 11. So this would be an 11th degree polynomial. In fact, it's a 1, 2, 3 11th degree trinomial.